we will investigate what are the possibilities of this residual streams and how can we turn them into something valuable. This is also shown in this small
Makers,
video.
we all make quality products. From a raw material to an end product, the whole production chain works as efficiently as possible. In a circular economy, we want to work on smarter chains. To do so, reuse is essential, recycling raw materials as well as seeing the value in waste streams. Your company's waste might become a resource for a whole new product. Therefore, we present Wanderful.Stream, an Interreg project in the Meuse-Rhine-Euro region, which allows us to get to know companies and their waste streams and map them out, because all these materials can spark new ideas. Wanderful.Stream connects small and medium-sized companies with designers, engineers, and business developers in order to turn waste products into new materials and applications. Something that is useless to you becomes useful again, and it's win-win for everyone. Although your waste flow may seem like a trivial matter, it could matter to others. Let's work together. Visit www.wanderful.stream for more information.
So in circular economy, you know that the goal is to keep resources in the loop as long as possible and at the highest possible quality level. So that is what we do in this project. Now, how can SMEs in the EU region participate? We start with a survey. We want to know the interest and the waste streams of the SMEs in this region. So if you're interested, you can fill in the survey. And you can do this before the end of the summer, because then we will make a selection of the next challenges. How does it work? SMEs fill in the survey. After this, the company is contacted by one of our business developers, and they will do a more in-depth needs analysis of the company. Out of all these needs analysis, we select some challenges, and these challenges form the basis of a bootcamp, a 3-day bootcamp where students, designers meet, and they will work to find solutions for the challenges of the SMEs. Out of these concepts that are created in the bootcamp, we select the most promising ones, most innovative ones, and we the innovation track, and the outcome of this innovation track will be this prototype where we valorize the waste stream. What is this innovation track? So starting from the need of the SME, we add from the project expertise from technology, design, and business development to create these prototypes. This has a market value of 20,000 euro. We use internal and external experts, and we offer this to SMEs. So the SMEs do not have to pay the cost price themselves. This is because we know that in SMEs, there is a lot of innovation. Good ideas are often laying on the shelf, but there is no resource or time to really develop this. So that is why, especially for the SMEs who do not have a big R&D department, we offer this expertise, and together with the SMEs, we will develop these innovations. We have 2 of these innovation cycles. An innovation track will take about 9 months. And the first innovation cycle has started, and we are developing the second one at this moment. So in the first innovation cycle, 10 projects have started. So at this very moment, the designer, the technology expert, and the business developers are working on solutions, different scenarios for the waste streams. And in November, we will have the first results and share the results. The second cycle has been opened. There's an open call for SMEs. And as said before, we are still looking for SMEs to participate. So join us today. In the end, we will have 24 of these tracks. So 14 possibilities still open to join. Here you find the link to the survey. We are not only inviting SMEs to join our network, but all experts in the EU region that have some experience or interest in circular economy are very welcome to register on our mapping tool. The idea is that we create a network of businesses and experts in the EU region that want to work towards the transition of circular economy. Through the tool, you can find easily very interesting contacts. You can directly contact these people and start new collaborations, even outside these innovation tracks that we are offering. So have a look there and register your company or your institution there. That's it for Wanderful.Stream. If you have questions or you want to collaborate, please contact me or anybody else from the project, and we are looking forward to collaborate with you. Thank you.
All right, thank you, Sarah. Yes, and as she said, feel free to contact us if you want to work with us on doing this project. Now, our first speaker is Elma Durmicevic. We didn't have the chance to do a pre-roll before the meeting. So Elma, I hope you're there, and feel free to start your screen if you have a presentation to share. Elma is the founder of the European Laboratory for Green Transformable Buildings, which is long for the GTB Lab. She's trying to introduce a system shift in the building sector, and she will talk about the new philosophy where waste is considered a design error. So Elma, please go ahead.
Yes, thank you very much. Thanks for invitation, and I'm glad to meet this new network, which is, I think, quite compatible with what we are working on. I made compiled a couple of interesting slides. I hope I will manage to do it all within 20 minutes. Try to be fast. I'll start with this picture, which is 2 days old from our construction site. We finally managed to make a start of the construction of GTB Lab. This is the laboratory for green transformable buildings, and many things I will be talking about today are linked to this construction as well. So I'll tell you something about the GTB Lab. This is the laboratory. As already said, it is kind of international, but also national or regional demonstration platform. It is also a center of expertise. We're trying to build awareness for the urgency to start developing new construction concepts and design concepts that will bring us faster to the circular economy. It is also meant to be a kind of big circular meeting space of different stakeholders. They have quite a big network in that respect, and work together with knowledge institutions and companies, construction companies, and advisors, but also public bodies as a province and a ministry and so forth. The laboratory in general, the idea is about the GTB Lab, built around the paradigm shift from perception of buildings as static structures, and hopefully with the construction and transformations and demonstrations on the site of GTB Lab, we'll have a chance to demonstrate how this perception can be changed towards perceiving buildings as dynamic structures, which are designed for multiple use options, multiple use reuse strategies for building itself and for their materials. So that's the whole, the key issue around the development, and all tools and protocols that we are developing in that direction have to do with this great fundamental shift in the way how we see buildings in general. And that brings additional complexity to the system of architecture and construction in general, which deals with integration of functional, technical, and aesthetic systems, subsystems into a final system of building. And this new approach towards reversible dynamic structure increases also the complexity of design process later construction, as the design teams need to deal with dynamics of spaces of buildings. We need to define multiple strategies for use of building, but also use of systems, components, and materials. And that will bring us also to the discussion about the architecture and dynamics of architecture and how it will still remain a kind of coherent part of our society, and the part which is providing a cultural continuity for the future generations. So that will be kind of interesting aesthetic discussion that we are coming in. But going back to the talks of today, is the aim of GTB Lab is to demonstrate these reversible building concepts and the impact that such buildings and buildings design in such matter will have on new value propositions, and will enable us to design upgradable buildings and built environment in the future. And basically, we try to close this loop of material use and the material streams through the built environment, and eliminate waste by design, because everything starts with design. What we'll try to do with the demonstrators, and which will be happening on the site of GTB Lab, is to demonstrate that it is possible to reduce the waste significantly also during construction, but also during transformation of buildings. It's possible to reduce the consumption of raw materials, CO2, and also at the same time increase comfort by integrating natural light, air, and green in the buildings. So it's a kind of integrated approach to the better life and better quality of buildings in our new world of circularity. We do that by this designing and focusing on design for high reuse potential of buildings and their parts, and especially looking into the connections. One of the important aspects of this new generation of buildings, but also looking into exchangeability and design of functional independent parts of the structure, which can be easily taken out, and checking and analyzing the assembly procedures, which will enable us to design and deconstruct parts with high value recovery in mind. Because everything I've been talking about stands for new way of perceiving buildings, which I call reversible buildings. I developed reversible building design protocols during a European project, buildings as material banks, and continue to working on this approach further on. And basically, reversible buildings stand for buildings which have multiple layers, as you can see here. Buildings have multiple dimensions, and these multiple layers gain multiple future capacities, and therefore future value propositions. That's what we are then demonstrating and working on. That whole development is actually boosted very much in recent years. I've been working on this for more than 20 years, but I feel and see that these discussions are involved more and more in these kind of discussions. So there is a kind of awareness of urgency to move swiftly because of the state of the art today, environmental issues and degradation of our environmental capital, which we see today. There's something which we have inherited. The life support system that supports various ways of life on the planet is being destroyed by our actions and the way how we consume materials. And of course, built environment has a major impact on this situation. And we realize that the way we are consuming materials is creating and leaving behind a dead matter, which is not producing oxygen or clean water or whatever, and brings us to a very dangerous situation. The reason why we are talking today about circular economy, and we are trying to figure out the ways how to move away from this take, make, and waste economy. And the thing is that involves a lot also discussion on economy. That's why it's called circular economy, as our whole economy and consumption is consumption economy built on consumption of resources. And that is exactly the reason where things go wrong. Is if we want economy to grow, we have to consume more resources. But as we know, the resource consumption is built upon very old systems of industrial systems from hundreds of years ago, which are having very bad side effects for the future. And of course, brings us to the state of the art today, where the World Bank presenting the ecological footprints of countries per year indicates the countries which still have some reserves in natural resources. Those are green countries compared to their consumption per year. And we see that these colors and the planet colors rapidly red, meaning that there are more and more countries who consume more resources per year than they have at disposal. So that all brings us to the understanding that this kind of linear consumption of resources with increase of population brings us to the point where we will need many more planets in the future in order to sustain the life on Earth. So therefore, the discussion on the way how to change the system, how to redesign the system towards remake system, where the waste from one industry would be seen as a resource for another one. And when we look into building then and built environment, that means that we should come towards kind of understanding of our buildings and built environment as a big resource pool and bank of materials for future buildings, and that material streams through built environment need to be organized in that way. That means not only taking materials from the buildings themselves, but we also can sketch towards industrial symbiosis, where materials from another industries, as you see here, on cable carriers, which are dismantled, and wood is used for the facade, or this machine was used to build the steel columns, for example. So that means that we are shifting from a linear use of resources in construction towards closing the cycles, a circular one, where we need to create the smallest circle as possible when talking about recovery of materials. And in other industries, when we look into other industries, this is kind of very common approach. It's called design for disassembly approach. Exists in the car industry from almost 100 years, more than 50 years. The other product industries as well. But when we look at the construction, of course, we know that that's the most conservative industry, and it takes much longer to bring these new approaches into design and then construction. And the reason for that is, as I said before, because we perceive building as a static structure, and the construction is optimized around the reduction of costs and the time of construction, and we don't take into account that materials which we bring into building have different technical life cycle, but also different functional life cycle. So we built buildings, and what you see here is the relational diagram indicating the relations that elements have in a building in traditional housing in the Netherlands from the built in 70s. What it indicates is that basically all materials in the building have multiple relations, more than 7, and that is the reason why we are destroying building, because obviously it's very difficult to cut all these relations and take element out without damaging it and without damaging other parts. So that's the reason why that's happening. And what we are doing in the GTB lab is we are trying to reverse these relations with dependencies in building structures, develop new approach to understanding and designing structures, wherein from this dependent relational diagram, we will move more to more open hierarchies built on 2 very important indicators of that. Independency is creating buildings with independent exchangeable modules as cameras whose functionality can be adopted and by exchanging different functional modules of it. And this exchangeability by standardizing connections, again, experience of the similar solutions can be found in electronics and other industries, which are inspiration to what we are working on. Because these independency and exchangeability are the key for us to work further and identify the approaches in design and construction to allow for functional, technical, and physical flexibilities and reversibilities of structures. And that's how reversible building is designed, is defined. This reversible and circular building has at its core two key elements. It has its spatial dimension, and a real circular building should not be demolished at all. It should be upgraded and transformed. And it has a technical reversibility dimension where parts and systems are being recovered and materials separated for other use. And then in terms of design, I defined three dimensions of design of reversible buildings: is spatial, technical, and material one, which are built around the key triangle of reversibility, built on adaptability and reuse, supported by disassembly. So this is kind of general framework, maybe a very long introduction, but general framework which helps us to understand the performance of buildings with respect to their reversibility and circularity, and helps us also to cluster all buildings from irreversible to reversible, and develop also measurement tools to indicate which parts of structure of built environment is reversible, which are not. As you can see here, I will not go further in there, but that's the framework on which we built, on one hand side, the design protocols, on the other hand side, tools and measurement systems that help us to understand the profiles, circularity profiles built on reversibility. In order to support designers, but also construction industry and everyone interested in improving built environment towards circular and reversible, I developed a toolkit which has on one hand side is reversible building design protocols, but it starts with also tools which assess the reversibility, technical reversibility of the building, and it says how easy it is to take element out. It also, another tool looks into the spatial dimension of a building, and it measures technical capacity to adapt to different functions. And there is a protocol for designers which informs designers how to design buildings and products that are reversible and will help us to come to upgradable built environment of the future. So this GTB Lab is bringing all this together. On one hand side, development of knowledge, sharing knowledge, capturing knowledge, sharing knowledge, but on the other hand side, also demonstrating and developing physical concepts, building concepts and products, and demonstrating how they look like. This is the view on the GTB Lab. As I mentioned, we just started constructing it, and it's the first spatial reversibility and aspect of spatial reversibility as being built into this structure as well. So building is dynamic and will be transformed once a year. It will change form and function basically as well as a demonstration of transformation of the building. Within the lab, we are developing new systems as part of facade system, for example, but also bathroom systems. As everything in a building needs to be redesigned in direction of recovery, easy recovery and transformation of spaces. But we also develop connections with the industry that will enable this reversibility of other parts in a building, prototype different new products together with industry, demonstrate how they work. We also help initiate new industrial processes in order to help industries to this start investing in that direction as well. Of course, demonstrate, and we'll be demonstrating on the site with GTB Lab how this transformation is happening without damages on the materials and with high value reuse of materials themselves. So this all brings us to the point that we will in the future need to design and perceive spaces differently, treat materials and use materials in the future differently, rethink the way how we build in the future, how we construct this. All we are talking about new concepts of construction methods and so forth, and most importantly, rethink the way we design buildings, as everything starts, as I said, from design. Much of this, I went very fast through many complex things here, and I'm very aware of that. Much of this you can find and has been integrated by European Commission in the circular economy principle for building design. So many of the indicators I was talking about have been taken over by the European Commission. There's also some guidelines as a result of BOMB project. There's also a book we published on 5 pilots where reversible building designs have been tested, and some exploration works with students and so forth. And this is, I think, my last slide. Within GTB Lab, we are then also trying to capture the knowledge, as I said, and we are building at the moment a knowledge platform for circular buildings, where different information from guidelines, policies, toolkits, but also pilot projects and circular building projects in Europe will be captured. So I'm looking forward to share the website of this platform after summer with you, and hopefully we can build up interesting data and bring in new interesting data to this platform so that it becomes more complete and gives us an overview of what we have at the moment with respect to the circular building. So that's my last slide.
Right, thank you. That was very interesting. Thank you. Also very nice that you're actually starting to build your first demonstration site. It must be a very nice feeling. Is there anyone who wants to ask Elma something? I didn't see anything pop up in the chat, but if you unmute yourself or type in that you want to ask a question, feel free. In the meantime, Elma, how is the industry responding to these kind of initiatives? How is that going? Because I can imagine
I've been working with industry for 20 years, and more or less also thanks to that industry, which we do call conservative, but they of course have to understand in advance where things are moving. So I've been talking with them 20 years about this subject and how they need to make steps and shifts. And therefore I know very much how difficult it is and complex, especially for big corporations and companies, to run through new systems through the whole company. But I mean, I built up a kind of network around this, the GTB Lab of 20 construction industries who most of them are following me from 2009. So that means that they are really pioneers. And I do see really in last 3 to 4 years, many more industries coming up, receiving in last year really mails from directors of companies wanted to talk about the ways further. So obviously the awareness is there and momentum is there, and now we have to make together the steps towards circularity. It is just the first step. First, you have to build the awareness. On the other hand, very often when I give lectures and everyone asks me, am I positive about the developments? I have to say on the other side, things are still moving very slow, too slow. But obviously, I think now the acceleration will happen as I do feel that the awareness is there and the companies really start actively thinking about their role and what they need to change. So there is hope.
All right, I see that Natalie has a question. Natalie, if you unmute yourself, you would be able to ask it yourself.
Hello. Yes, I can see myself. I hope that you can hear me.
Yes.
Really enjoyed your presentation. Thank you very much. I was wondering, in terms of the reversibility, some of the pictures that you were showing were looking as if it was focusing on just the kind of the structure of the building. But have you also thought about things like the heating and cooling systems? And if so, when you do your once a year reversible or reconfiguration, should I say, what happens then? What problems or what solutions have you found in those areas?
Yeah, that's one of very important parts of the experimentation. So we started construction, as I said, 2 days ago, and this year we are building up the first phase. Most of the parts that we are going to build will be a core of the structure, and the design of the core, we took special attention to the installation surfaces. I had very good advisors here, the top advisors in the Netherlands. We looked into the ways how to build up the concept, where the installation concept, which will enable us kind of modular approach to installations as well. And that is one of the things we'll be exercising and actually illustrating that you can develop integration of installation concepts also in a way that will support your transformations of the building without demolition. You need to, I'm always telling, especially to the students of architecture, when I work with them in design studios, we will need very smart designers and architects in the future, because I believe that architects will be more involved in design of invisible, the cores, which will basically give a life to the building in the future. And very often those are really the parts which you don't see at first place, but are very important parts. So that is absolutely a very important part of the exercise.
All right, thank you. I don't see any further questions, so I suggest we continue with our second speaker, to Errol. So Errol, while I introduce you, feel free to already start sharing your slides. So Errol is an architect, and by collecting and connecting and enriching data, he contributes to the transition of a region to make the construction and the demolition world more circular with a very interesting data system called Cerdax, and he will tell you all about it. So please go ahead, Errol.
Well, thank you very much. I will skip to the common intro, so we get some more time. Hopefully you will see the screen.
Yes.
Yeah. Okay. Oh, and you see my face. Oh, well, okay. Okay. Thank you for the introduction. Just want to say something about our system. It's called Cerdax, and it's a data system that we developed, providing information about properties based on measurability and accuracy. It's an information system that manages materials during every step the material has to deal with in the real estate process, based on actual data and smart techniques. Circularity within the demolition construction process can be anchored and effective and efficient use of raw materials. With an inventory app, we easily map and register materials present in buildings and can be read 24/7. We have designed several applications within this system. I want to discuss some of them with you, and the most recently is the one in the deposit in the green is the blockchain module. Just for the short recap, we use the blockchain at this moment on several pilots, and one of them is together with the Ministry of Internal Affairs, how we can use data by extreme happenings. Maybe you remember this one. It's a Greenfield Tower, and it was caused by a malfunction fridge freeze on the 4th floor, and due to flammable cladding, the entire building was on fire in no time, and the tragedy resulted in 72 deaths. And the question was of who was responsible for that one. And we are working together with ARA. It's a large engineering and consultancy firm with headquarters in London, and they are also present in the Netherlands. So we're doing a pilot with them in the rail program in the UK, because they were interested in the applications to the blockchain to create a long-term contracts to can be secured. So we focus on one material. It's the facade cladding at the outside, and we follow the whole process from manufacturing stage to operational stage to disassembly stage and the design stage, and we collect all the data into the material passport and connect it to the blockchain. So we make an architectural infrastructure to secure the information and to know in case of a disaster. So we can provide with the secure data information so that we can track the process and product to find out if it's due to renovation, maintenance, to toxic of the material, or the reusability. Another tool that we designed in Surdex is the material passport, and it starts with the material passport. It gives material identity, and you need that identity to terminate by assigning a number of unique properties, like including the quality of the material, the quantity, the size, the color, the recyclability, and the dismantling of the material. So with a license, you can get into the data system of Surdex, and you get into the data information platform. And then you have the material passport tool, and it provides insight into the identification and validation of the materials and at any desired level. So it's a product, a space, and on a building level. The collection of all these passports, we give buildings more value because they make it easy to repair and recover materials during renovation or demolition. So all material passports, they have a code according to the NL, we call it the NL SFB standard, and they are automatically generated and stored in Surdex. So that information is always available and current. And the generation of the material passports is possible for existing buildings as well as for new constructions. What we do now with the Surdex system is that we connect the material passport to the blockchain module, and it gives the material identity and property rights. And the blockchain does not allow fraud to be done with information. So the material passports are processed in a digital data system further. So what does that technology give us? Just resume, it gives us property rights. So the material passports can be connected to the blockchain. It's not necessary, but it can. The passports give the material's identity, and the quality of the material is made transparent. And it's safe data. Every material is verifiable. Information is immutable, and new information is added on top of the old information, the ledgers. Another tool that we designed in the Surdex system is the CO2 balance. Well, actually, we believe in a CO2 label for new buildings. It's an extension to the energy label because we think that only the CO2 savings by the energy transformation is not enough. The CO2 reduction achieved by using materials from existing buildings is also necessary. The reuse of the materials through circular constructions actually means that these materials do not have to be produced again. So reuse therefore also stands for sustainable energy in addition to the sustainability in materials themselves, because a lot of CO2 is released during the production of materials for construction. So how much CO2 is saved by reusing materials in a building can be done by linking a CO2 balance to a building material passport, which includes the CO2 impact of the quantities of material for each material. So a CO2 balance therefore provides a single overview of the social value of the reuse of materials in terms of CO2 emissions saved, as well as in euros, as in tons, and by linking the balance to the CO2 price. Because we think that you have to count the building blocks of your building into the climate impact. And all those calculations ultimately result in CO2 savings. So not only per building, but also per region and in the Netherlands, in total Europe, worldwide. And for me, that's the best way to imply CO2 reduction. Based on indicators such as energy, reusability, and material. So the score can be used to upgrade the circular intentions and translate it into finance of the CO2 impact, and gives an assignation of the reuse potentials in upcoming years to use for exploitation of real estate. So the higher CO2 label, less cost. And that is what I think is a big proponent of introducing the CO2 label for buildings, in addition to the energy label. Even better to connect it, I think. So that all parties have one common carrier to apply the CO2 reduction. Next step is to connect the output of the CO2 balance again to the blockchain. So we validate the material now and in the future. So we validate ownership to create economic rights to that material. And all those tools that connects are the models all together. They are showed in service in a performance dashboard. So you can do, it provides a visual presentation of the performance of a project based on circularity, on finance, on CO2 emissions now, and gives us a assignation of the reuse potential in the upcoming years. So these tools makes it easy to demonstrate, report, and share results with stakeholders to make better strategic decisions. So, but if you want to dive into the technical system, feel free to ask a free demo and watch us on the website. Just a last recap. For this, all of this, to use the service to connect the materials on the construction level to the building set level, you need properly working data system, and that makes the construction circular, because you must have, for that one, you must have the right information about inventories of the existing materials in the buildings. And if you want to trade that one, you must have the inventories of materials in the new building, and then you can link it to another, and then you can calculate your CO2 balance, and that is necessary to determine the price, and therefore you can use the blockchain. Just a recap, so what we do with that one, like I said before, we're doing it with ARP. We use the Surdex in a lot of house organizations with governments and etc. But just some projects. This is one, like I told you before, to show you what we can do with the database. So that is the project with ARAP. We are together with Elma. We are in the digital deconstruction project. It's an Interact project where we combine different kinds of data together to make a new digital tool. We are making at this moment a digital market trading platform. We're doing that with Brightlands and with other partners. I just want to show, because you have a lot of designers in this meeting, but I think it also starts with crazy people, with designers who we challenge to break the boundaries, to experiment the max. So just some short pictures that we do with the project of City Live, where we challenge the designers to experiment, we do it every year, to dare them and to break the rules of design, to use reused materials as a source for new materials, and to be an inspiration to restart the process. Because waste, we are saying it's no way. So that was my very short, I don't know how short it is. Is it in time? Yes, it is in time for now, my presentation. And thank you for your attention. And I think maybe you have some questions or not.
Yeah, all right, thank you. Yes, you were perfectly in time. Yeah, if you have any questions, please type them again in the chat box. Well, you said that you are actually working with the GTB Lab. Is Elma actually using the Surdex blockchain system
Yes.
And how does it work for her project?
Yeah, well, we have, but Elma can confirm it. Actually, we're working with 10 organizations, and we have 4 data deliveries. Elma is one of them, and the other one is the blockchain and Surdex. So And we have 4 different kinds of data deliveries, and we are now in the process of using the pilots. And one of the pilots is the Stadskantoor in the gemeente Heerlen, and to use and how we can connect it to design a new tool for, and we call it a deconstruction tool for the designers to really to look into the database. What do we have? How we can transform them with the method of ELMA into new designs, and what is needed for that one. And it's a project but it takes another 2 years, and we hope to finish it with the market tool for all Europe.
Just to indeed add, so we are developing a digital deconstruction platform for which we hope it will be one-stop shop, I'd say.
One-stop shop, yeah, that's a
yes,
good
because we all know that the construction industry and all stakeholders in construction are kind of, they do worry because there are so many initiatives and systems and tools and so forth, they don't know where to go anymore. So we need to cluster. That's why we also decided to develop a digital construction platform that integrates 4 technologies together. 3D scanning, that's one technology. Reversible, that's my own technology. I mentioned something about that. Material database of Errol and blockchain of Errol. And we are bringing that all together. We are bringing that all together on one platform, and we have a partner in Luxembourg, Institute LIST, which is integrating the modules. And the idea is that this platform will support decision-making about the construction reuse strategies.
Yeah, but it would be a very nice one to connect it with your Interact project.
I was thinking as well, because the timing is the same. Our project is also running until June of 23. Mm-hmm. So it would be nice to, maybe we can have a joint symposium or something like that next year.
Mm.
Yeah, why not? The timing is indeed very similar. Natalie, you have a question, an interesting one. Feel free.
Yes, hello, I'm back again. Apologies. So I was interested by your point around the carbon labeling. And I'm just wondering, I've seen quite a lot recently of different labels, different certifications that either buildings or products can get. Mm-hmm. But it seems like there's no one standard in the industry. Mm-hmm. Back to your point, Elma, right? Different people are doing different things. Mm-hmm. So do you think there is a need for standardization across the industry? And if so, how best could we achieve that?
Yeah, yes, there is a need, and the need is going to we're going to fill it at this moment with I don't know the English, but the Minister of Internal Affairs, and we're working on a CO2 label, and we're also working with CB23, it's Circular Both 23, and that's a national platform where we introduce a standard material passport, because like you said before, that the market already introduces a lot of different kinds of material passports, and organizations don't know anymore where to shop, where to buy, what. So that's a difficulty one. And as soon as we all want the same thing, circularity and CO2 reduction, we decided, not we as a personal organization, but we, the whole country, and there's about 40 organizations in it, to create one standard material passport. But that is already in process for now for 3 years, and it's still not on the market. It still has no value. So meanwhile, everybody's doing their thing, and you need the government on every level, on local level and on national level, to come up with some rules, because there is still that is what we notice. The lack of urgency is not yet there. We are working on it. Elma is already working for 15 years. We are already working for 10 years. There is process and progress, but that's only my opinion. We really need an independent organization like a government who will set up some rules.
Yeah, I agree. All right. no one else with any further questions? I believe not, and otherwise we'll keep them for the end.
Sure.
Then we will continue with Huub Loze. He's the co-founder of OMLab. Huub, feel free to already share your PowerPoint in the meantime. And the OMLab is a bio-based design and project studio, and they research, design, and create with 100% respect for nature. And today he will tell you how they do this with circular raw materials, and which are coming from sewage treatment and drinking water production. And some of their products are even on display in our museum here. So Huub, please go ahead.
Okay, thank you. Thank you. Maybe on a different way of working with the circularity. I merely start with my hands in the material. That's my way of doing it. Constructive circular 3D printing, that's the focus for right now. I'm doing it in designing and making. We thought to take the responsibility of design and to work in a lab in which we research, we make, and we share. And our mission is to design and make it with 100% respect to nature. This 100% respect to nature will make every decision as a designer different. And that I'm in a small company. For me, it is possible to make these decisions. I'm aware of that companies are not able to make those decisions as a change, but that can be a mission, that can be a goal to make things with respect to nature for a full 100%. My inspiration is partly from someone like Denise Notenboom. She's a traveler in Portugal and saw all the problems Earth is facing. She says we have to do every effort possible to make it different. In this stage, we have to use trade more often and eat less meat. I'm doing this, but as a designer, I can do more. It's very nice to listen to her talks. Inspiration comes from someone else who also works on something like this is making too, the Maduster idea of Thomas Rauw and Sabine Oger. Material does matter, and I am totally convinced that buildings are a container of material and functional parts. So I'm very glad those speakers in front of this of my lecture are elaborated but it's more. There are some really nice examples how designers use it as in an artistic way, those materials from circular source. And in the end of my last of the lecture of Errol, he showed us indeed very nice artistic examples. But it becomes much more difficult to make those circular material really constructive. And in this, I chose for working with a good selection of the material in combination with digital and new ways to fabricate. The choosing of the material, I focus on bio-based and circular. So I hardly use any fossil-based materials or materials that come from the depth of the earth. So that makes your choice different and needs a lot of innovation. But it also needs innovation of the economy. The economy is bio-based economy appears to be difficult because all the materials we design as from bio-based are in start are a little bit more expensive. So the economy has to be willing to think of the effects. And yes, the government is now making rules like CO2 calculations to urge companies to choose better. And circular economy is also something that is slowly getting economically interesting. But there's a lot of work to do. And it's helping that systems like my former lecturers told me about are working on. But in the economy, there's also a design necessary. And in Ireland, they're working on multiple value creation. And this is a way of different thinking about economy. And the economy in the multiple value creation is also calculating the social benefits or the ecological benefits. And this has to be even more important than financial benefits. But how do we work with this system? How do we work with this? How can it be a solution to make different buildings, to make people choose for something else? Always this wallet, the euros are more important than the social benefits. We need to find a change. In my career, I designed an example, a shop in Bergen-op-Zoom in the Netherlands, as an answer to a question of the Bergen-op-Zoom community, to show the people what's already available as a bio-based product. Bio-based products are made out of plants, and I showed this in the pop-up store in Bergen-op-Zoom in 2016 by showing also the vegetables and the products next to it. So yes, plants will be able to make plastics, but also make possible construction materials. And it really feels good if you make this choice. We work in a workshop. This is the workshop. It's a small workshop. And 1 year or a little bit more than 1 year ago, we started 3D printing with a new recipe that was inspired by work of Marit Sauerwijn. I saw a design, 3D printed design out of chalk and albinate on the Dutch design. But we started in this workshop, and it's in the middle of nature, so the nature is part of my living, and every day I enjoy it. So the value of the nature is for me is very noticeable. The focus now is on the 3D pasta printer. I created a past like mortar, like a concrete mortar, a past or a clay that you can make things with a 3D pasta printer. This developed into a really working construction material. We call it a material prototype. We started with clay printing, but clay is a very, it's a fantastic material. We know it already, we build houses from it, but it's also nice to print with it because it's very solid. It's nice working with it. But the pasta we made firstly didn't give us the opportunity to build strong and solid, high objects. So we developed this with a material research, and we tried to combine different materials into something that will be solid while printing. That's the material research we did with students, with my own exercises, and I have a short video in which we explain it also to the public. I hope the sound is well, I don't think it will show right now. I think you have to watch the video later. I can't show it right now, just because it opens another screen. I explained in this video that I try to make something that is possibly making a path that will help to replace concrete for a little bit. Because only if concrete is replaced by this a little bit, it's gaining a lot. The material I make now is made from the chalk from drinking water and hardware. So the chalk you find in your cooking ware, we use to make this paste. Another important ingredient is our old toilet paper. In the water installations, the sewage installations, they sieve out the cellulose from our toilet paper, and we use it as an important stabilizer of the past. And it's really nice to work with those two very circular materials. Another circular binding material is Carmilla. It's a wire-based binding, biopolymer, also made by bacteria and the system of clearing the sewage sludge. You can read more about it online. And then I did a little bit more binder, and I introduced alginate. It's a binder made from green material from the sea. So this recipe I elaborated to something that is really helping to make bigger parts. We made samples. We made a lot of samples. We made also samples to be tested in physical property machines, because we need those numbers to calculate how we can use it in construction. We also experimented with colors, and the colors we made are made now from also recycled ingredients. So the black, especially the brown, and the ochre are made from materials from the drinking water purification. The science became more complex, while if you work on the technique with 3D printing, you gain a lot. We need a solution to dry the objects, so we can't use a lot of material, but we need a lot of air or ventilation to dry the objects. That's one of the decisions as a designer, as a constructor, to make. Other things are reduce the use of material, of course. And then complexity gives you also an opportunity to introduce technical details. How to connect different constructing modules, or how to combine it with electronics or air systems. So we are working on several of these design questions. Some of them are made better possible in 3D printing. by using coding techniques and using Grasshopper and a good tool for 3D modeling. The 3D printing looks a bit like this. The past is now a lot more stable than in this movie, but it's moving, so you have to make connections in your parts to fix the plumbing printing. So these connections in the design are helpful while printing. The actual project we're working on, I explored a few. The next Dutch Design Week in October this year will show a very big construction. But last year, model 1 to 4 was already displayed. We work on a project with raw materials suppliers, with professional designers, and we work together with students from the Hogeschool Arnhem Industrial Design and students from Chemical Process Technology in Breda, and this helps us a lot. The exploded fuel. The exploded fuel is very interesting for architects because it displays in an explosion of a house all types of materials that are bio-based or from circular sources. And this exposition is right now in the Ghent Design Museum and will be displayed in the Fundatie, the Zwolle, in coming month. And after that, it will travel to the Floriade, and it will be opened, I think, in April next year. So it will be on display a lot more. It now shows all kinds of materials in the experimental phase, and our toilet room made out of the past is showed on the right. We're trying working on this next version. This is the version we showed there. It is 1 to 4 model, and now we are working on something much bigger. All the information about this exploded fuel is available on the site. It's very nice, elaborated, and illustrated site. With also a lot of exact and technical information. The next one is skill 1 to 1. So we will build a toilet room 1 to 1, the wall and everything. I have an example here we're working on right now. So look at the little screen next to it. We're working on a combination of air ventilation and construction. So we try to make even more inspiring. These are the samples that are displayed right now in the Discovery Museum. I have one little one here, but the big one is a better example. You can feel it in the Discovery Museum. It really feels like a little bit of concrete, and it smells also a little bit. So we have to work on it because it's from sewage material. This is a look inside of the building block we're working on right now. I'm working with a student from the Hogeschool Arnhem. He is big albums, and he also from Limburg, and he is finalizing his study on this design science. Ventilation channels we try to integrate, and we combining bigger building blocks than this one into a wall. So you will be seeing it in October. I'm inspired by people like WASP printer designers. The WASP printer is an invention of Italian designers. They made a very nice housing example with nice design of ventilation and construction technique. I can show the movie. I think I have time enough left. Is it? Misha?
Yeah, go ahead. I'm not sure if there's sound. But
What did you say? Sorry.
I'm not sure if there's sound with the video. We don't hear it anymore.
Oh, okay. There's some with my video. Maybe I have to start sound sharing. Is it possible?
Yeah, if you stop the sharing and then reshare again and then click the button share audio.
Okay. Sure. Yes.
Or we can share also the video afterwards if you'd like. Then.
Okay. Maybe that's better. That's better. So yeah, we share a video in another post. One of the partners I'm working with now is Brouw. It's nearby Arnhem. They are really good in 3D printing with a high grade of technology inside it. They can use all the features of 3D printing and work together with intelligent software to make more things possible. Soon I will be doing a pilot with them and hope to share it with you afterwards. The advanced students brought up with some nice report and some numbers with physical strength tests, and they assured me that this material is I'm working with, created, is comparable with C8 concrete. So there is some work to do more and more. Working with raw materials, circular raw materials, is a challenge, and it's also a challenge for the suppliers. So one of the suppliers, Agri Minerals, asked us to bring up a project to work with designers and to make sort of proof of concepts how to use this circular raw material. So we started with few studios, design studio, artistic design studios from Arnhem, and we created some objects. These are designers. They impact through Wonder, so you will see. They designed an object to help the nature, and we call it an oase. And this oase will give a chalk as a material to regenerate the earth that is too sour at the moment, and also give some nutrition to the earth together with seeds. And this is another part, one of the materials we develop is that we can let it be regeneratable or very helpful to nature. And now in nature, in the Netherlands, we supply chalk to the nature to help the earth and be able to let grow more normal plants. This is one of the objects we created, and we will show more in Roda Museum in Apeldoorn. We wanted to make this really big object in nature, and we dream of making this happen with a 3D printer on rubber tracks, and drive it into the nature, and then print it on site. That will be fantastic. I managed to do this. All the material is available in different regions, so we don't have to transport it a lot. So it will be very nice to help nature a bit in another way of thinking. Other project we work on within Maag is with architects. We spoke with Mark Vermeulen. You probably know him from Dutch Mountains that we will build in Eindhoven. And he also made very nice video together with Nima Helder, a strategic recognition exploration on bio-based building. Architects are looking for bio-based materials, and he explains why this is so such a good choice. Next project we were working on is a project with a housing corporation. They have a lot of buildings or houses. They would like to renew, but the materials that come from it we will use in new objects, and probably with 3D printing too, or in combination with our past. And then we hope to deliver some nice objects that will inspire new architects, but also entrepreneurs who want to make new buildings. So to show that there are other possibilities. So there are some expositions are going on right now. The exploration is traveling. One of the building blocks is now in the Discovery Museum. It will be displayed in Nijmegen in Kenniscentrum Circulaire Bouw. As we speak, there is a meeting right now there. It's called Circulaire Oogst, in which they research some buildings with this multiple value creation method. And they're discussing our building block with the mayor of Nijmegen. Into biodiversity, we will be displaying our rock, our oase in Apeldoorn, and next October in Florian we will be showing the exploration. Yeah, that's a big challenge going on. We would like to make our material as worthy as clay, and how many houses have been built with clay, with building blocks like clay. So we look at the clay building blocks production to learn from. I call it technomimicry. We like to learn how to make this material conquer a big part of the market of building materials. But there's a long way to go, I'm sure. And maybe some of the parties are present in this lecture can help. I don't know, but I'm sorry. I will continue. So learn to share the things I make. I'd like to share with a lot of people so we can finally achieve more on this earth. There's no second earth, so on this earth, yes. Okay, thank you.
Right, thank you. I hope everyone was able to follow the biggest part of the presentation, because the audio was a bit hard to follow. We experienced during the test already, but we weren't able to really fix it. But I hope the video and the together with the audio and the slides were still okay for you to follow. Is there anyone who has a question to ask for Huub? And as said, if you want to see the bricks that they printed, they're on display here in the Discovery Museum. So feel free to come look for them and smell them maybe. I don't see any questions coming up. No. All right, so Huub and the other speakers, thank you very much. And yeah, we hope to see you soon. And the corona measures are drawing to an end, so hopefully we can meet in person again and do these kinds of upcoming events live without any technical interruptions.
Yeah, I hope so too. Yes. I saw the audience asking for what's my biggest challenge. I saw it popping up. Yeah, the biggest challenge is to build a house with this past, and then I hope without as less as possible other materials. But there's a long way to go because the resistance to the weather, but also the construction, the physical properties are still a challenge. But as I told, I'm working on this for only a year. So if we take the development time other materials have went to, then we will get there. Is that an answer to your question? What?
Most I could hear yes, this answer to the question, and of course I know design and development takes time. You have to find out about regulation, technology, everything together, and also material science is also important. But maybe it's always good to follow new examples, and also I would say look what is happening abroad. So especially in 3D printing, a lot is happening in Belgium or in the UK and even in other countries. So I would suggest check them too.
I'm checking it every day, but as we said earlier, someone from America is visiting us, and that's an explorer in 3D printing all over the world. So George Ross, he's called, watch his videos, and you will see a lot what's happening in the world in 3D printing. Yes, thank you.
Yes, all right. No more questions, I think, in the chat. No. All right. Well, I said thank you everyone for joining, and let's hope to meet in person again very soon. Thank you all for joining. All right.
Thank you for organizing.
Sure.